The next important term is p-value. Basically, this p-value is related to hypothesis testing. So, what exactly this p-value is, and what is the significance of p-value? So, basically, a p-value is a probability of null hypothesis is true. So, the p-value refers to a probability of what? It's a null hypothesis is true. If the probability of null hypothesis is greater, in that case we can accept that hypothesis and null hypothesis basically. And if probability the p-value is lesser, in that case we can reject that null hypothesis. Then what is null hypothesis? Null hypothesis is the concept where hypothesis is nothing but an assumption. Okay, so in this case assumption that treat everything is equal and similar. So that is the assumption. So you can take example of null hypothesis like the GDP. India's GDP before um, pandemic and after pandemic uh, will will remain same. Okay. This may be a null hypothesis, or we can say so. Uh, you can take one more example of a null hypothesis is that the the average height of a male is greater than average height of females. Okay, so that can be assumptions, and that assumptions can be called as a null hypothesis. Now, when to we reject or accept this null hypothesis? So, if the probability value is lesser than or equal to 5%, we can say so 0.05, then there is a strong evidence against the null hypothesis, or we can say you can reject the null hypothesis. If the probability value is greater than 5%, or in that case it's a weak evidence against a null hypothesis, so we are failed to reject the null hypothesis, so we can accept that null hypothesis. And if the p-value is equal to 0.05, then it's a marginal uh, value, we can say, and we can go on either way. Okay, this is a concept of null sorry the p-value. So if in case of the hypothesis testing, we have to we need evidence, and on the basis of that evidence we can do certain calculations and calculate the value of p. And on the value of p, it's our decision. In certain cases there is a business decisions, so we can accept or reject that null hypothesis. Okay, so next question which is related to again it's statistics is what how to treat outliers. Now what do you mean by the outliers? The outliers are the values which are abnormal, we can say abnormal. That values are called as the outliers. Like suppose if you are sitting um, on a dining table, and the employees of a certain company are taking a lunch, and if you consider the um, average salary of this table, uh, that value uh, so will be equal to the salaries of each and every person who is a employee who is sitting on that table. Okay, but when the CEO comes to that table and sits um, for lunch. In that case, if you calculate the average value, that average value goes higher. So that salary of that CEO of that company uh, is an outlier, we can say. Yeah. Or the average height of any male is, suppose if you measure the uh, height of uh, male, in that case it will ranges from the 5.5 to 6 feet. But if some person is having the height which is 7 feet, in that case we can consider that is the outlier. Okay. Now the same concept there in the data set also, there are certain outliers, and that outliers may affect the values, average values. So treatment which is given to the outlier is very important as far as the machine learning is model is concerned, because whenever you give the input to the model, and if the outliers affects the average values, so the model will adapt that values and gives the inaccurate results. So to avoid that, we need to treat the outliers best possible way. Okay. And now if the outlier in certain cases are the garbage values. Suppose there are the weight, in weight column the weight is given in the numbers, but in certain cases if there is a the ABCKG, this is the garbage, you can drop that. The range of the values in the column from 0 to 10, and if suppose the 100 is there, this is the outlier. Directly if you can drop that, but in certain cases the outliers are very important, that carries a very meaningful information. So every time dropping the outlier is not the best way. So in that case, uh, to how we can treat this outlier, that outliers can be treated by using uh, a different models. Instead of using a linear models, you can go for the non-linear model, or you can do the normalization of the data. So what is normalizations, we will discuss afterwards. Then you can choose the algorithm which do not affect by the outliers, like a random forest. Here uh, yes, if there are large number of outliers are there in the data set, in that case you can go for what, either you can replace it with the 99th percentile or first percentile values. Remove if it is possible, or you can bring them into the range. So likewise you can do the normalization, you can treat these outliers. Okay. Next very important questions as far as the data is concerned, that is the normal distribution. So what is the normal distribution? So basically all the natural things follows the normal distributions, we can say. So what exactly the normal distribution? So normal distribution is nothing but the all the values will follow a bell-shaped curve. So maximum values will fall under that curve, bell-shaped curve, and that bell-shaped curve is symmetric. Basically, this normal distribution is also called as the Gaussian distribution, because it is discovered by the Carl Friedrich Gauss. Okay, so it is called as the Gaussian distribution also. So it's a bell-shaped curve. So why normal distribution is very important? If data is not normally distributed, it is difficult to analyze. If it is normally distributed, then some insightful or information can be drawn from the data. Okay, so we will see the characteristics of normal distribution. So first one, it is the bell-shaped curve. It is called as also a Gaussian distribution because discovered by the Carl Friedrich Gauss. Then the mean is equal to median is equal to mode. So mean is the average value, median is position wise it's a middle value, and mode is the most frequent value. So these three are equal, then we can say it's a normal distribution. The curve is symmetric about mean, and it retain its shape after transformation. What transformations? If one normal distribution is multiplied by another normal distribution, the result is normal distribution. If you can make the addition, then it becomes a normal distribution. When you can make the convolution of normal distribution, it is normal distribution. You can do the Fourier transform of normal distribution, it is normal distribution. So shape will remain same after the transformation. Okay. Then there is another rule that is called as 68, 95, and 99.7. So what it is? This rule tells us that a 68.27% of data lies within one standard deviation of mean. Then 95.45% of data lies within two standard deviation of mean, and 99.73% of data lies in three standard deviation of mean. So mostly the uh, most of the data is fall under the three standard deviations. Okay, and the standard deviation gives the idea about the variability of the data basically. Yeah. So next one is what is standard normal distribution. So whenever we can uh, bring the transformation of any distribution into a normal distribution. So for that we can transport, because we have to transfer. If any data is not normally distributed, then if we want to make it normal distribution, then there is the concept of standard normal distribution, where we can make the mean is 0 and standard deviation is 1, and for doing that we need a z. So z value is x minus x mean divided by standard deviation. Okay, so z value tells us how much standard deviation the value is the value from mean. So it's a z transform, also we can say it's a. So z value tells that how much standard deviation is the value from mean. So suppose we are having a z value is 1.25, means the point is at 1.25 multiplied by standard deviation, right? So yes, so that is the standard normal distribution. So most of the cases when we have to get the data, uh, process the data, in that case we have to bring the data into a normal distributed by using this normalization, we can say standard normalization basically. And for that we can use this z normalization. Okay. Now next one is related to is the skewness. If data is leftly skewed or rightly skewed. If data is not distributed normally, then it is left skewed, means the tail is on left hand side. Okay, that is called as negatively skewed also. uh, Tail is on left side means there is a lot of outliers on the left hand side of the curve, and here the mode is greater than mean, greater than median, and median is greater than mean. Right skewed means it's positively skewed, we can say. So the tail is on the positive side or the right side, the outliers are lying on the right side, and where the mean is greater than median is greater than mode. Yeah. So how we can check the normality of the curve? The first, you can draw a histogram or KDA plot. Directly can uh, give you the idea about the normality. KDA plot is kernel density estimation. It's a continuous kernel. Okay, you can plot a QQ plot. Then you can see the skewness is less than zero point 0.5, and it's a negatively skewed. The skewness is greater than zero point 0.5, it's positively skewed. And and the kurtosis. On the basis of that, you can check the uh, normality of the curve.